Alright, so today we're going to be looking at finding the volume of prisms. A prism is a three-dimensional figure named for the shape of its base. The two bases are always congruent, which means they're the same polygons, and all the other faces of a prism are parallelograms. Here's examples of two different prisms. So here we see the top and the bottom are both triangles, so this is a triangular prism. And here our bases are rectangles, so this is going to be a rectangular prism. Now if you notice, then even though the base here is a triangle, that front face is still a parallelogram, as would the other two. Same thing here around our rectangular prism. So when we're finding the volume of a prism, it's always found by taking the area of the base and multiplying it by the height. So a lot of times you'll see a big B times H, which is different than our area model, which sometimes you'll see like area equals little base times height. That little base is because they're talking about actually like the length. So here we're not using that formula. That big B always refers to the area of the base, and the reason they write it that way is because then it's the same formula no matter what the prism is, because you're simply finding the area of the base and then multiplying it by the height. Remember when we were doing area that it was measured in square units, but volume is always going to be measured in cubic units. Alright, so we're going to find the volume of the figure to the nearest tenth. Here we have a triangular prism because our base is a triangle. So our volume is going to equal the area of the base times the height. Since it's a triangle, the area of our base is going to equal 1/2 little b, the base of the triangle, times the height. So we have 1/2, our base is 6, our height is 5. Half of 6 is 3 times 5 is 15. So the area of our base is 15. I'm now going to take that 15, put it into my volume equation, multiply it by the height of my prism, which is 7. And if I do 15 times 7, I get 105 feet, which is our units, cubed. So why don't you pause the video and try this one on your own. Okay, so in this problem we have a rectangular prism. So once again our volume is going to equal area of our base times our height. In this particular one, the area of our base, so that big B, is just going to equal our length times our width. So here it's a 2 by 5, so we would do 2 times 5, which would be 10. I'm going to take that 10, put it in for the area of my base, times the height of my prism, which is 3. So our volume is going to be 30 centimeters cubed. Alright, so now why don't you try this one on your own? Okay, so here, once again our volume, this is a triangle, so our big B is going to equal 1/2 our base, which is 12, times our height, which is 10. Half of 12 is 6, so the area of our base is going to be 60. I'm going to put that in for our big B, times our height, which is 14. So if I do 60 times 14, I get that the area, or the volume, is 840 feet cubed. Now let's look what happens when you change some of the dimensions of a figure. So if we start with a box that measures 5 by 3 by 7. So here it would be this dark blue box, and it's going to be basically 5 by 3 by 7 tall. So its original volume would be 5 times 3 times 7, because the base would be 5 times 3, which would be 15 times 7. So it would be 105 centimeters cubed. If we tripled the length, so now you notice it's 3 across, so we have 5 and 5, but its width is still 3 and its height is still 7, what would happen to the volume? So now the area of our base is going to be 5 plus 5 plus 5, which would be 15, because we tripled the base, so here it would be like 3 times 5, right? Times 3, which is the length of our base, which would be 45. 45 times 7 is going to equal 315. Well, if I take 105, if I take 315 and I divide it by 105, I get 3. So basically, that same thing that I did to the length also did the same thing to the volume. So by tripling the length, I was able to triple the volume. So using that information, what do you think is going to happen when we triple the height? So now it's going to be 5 times 3, but then it's 7, 7, and 7. So here we have 5 times 3, but now that 7 3 times is going to be 21. So when you do that, 5 times 3 is 15. 15 times 21 is still 315 centimeters cubed, which is the triple of the 105. So by tripling the height, we once again tripled the volume. So now that we've tripled the height and tripled the length, what do you think is going to happen when we triple the width? So it's a 7 by 5, but now it's 3, 3, and 3. So here we have 5. 3 plus 3 plus 3 is 9 times 9 times 7. We still get 315 centimeters cubed. So we basically can generalize this and say by tripling any one of the 3 dimensions of a prism, you also triple the volume. Now let's look at an example where we want to find the volume of a barn. So we want to figure out how much space is inside the barn. So the volume of the barn is going to equal the volume of the rectangular prism plus the volume of the triangular prism. So here our volume of our rectangular prism is going to be 40 times 50 times 15. Which gives us 300,000. The volume of our triangular prism is going to be 1/2 the base, which is 40, the height of the triangle, which is 10, times the height of the prism, which is 50, because it's the same long edge, right? So 1/2 of 40 is 20. 20 times 10 times 50 gives us 10,000. So if we add those together, we now have 310,000 feet cubed inside our barn. Alright, so why don't you pause the video and try this one on your own. So our prism is going to be 8 times 3 times 4, which gives us 96 for the volume of that. Our triangular prism is going to be 1/2 our base, which is 8, times the height of our triangle, which is 5, times the height of the prism, which is 3. 1/2 of 8 is 4, 5 times 3 is 15, 4 times 15 is going to be 60. So if we add 96 plus 60, we get a volume of 156 feet cubed.